away. Off the desk. Not in your hand. Not in your lap. I do not. What day is the test again? Wednesday. Next Wednesday? Next Wednesday. So Monday we're going to go over the quiz and your flex day. That will be the last day to get your grades up, really, before the end of the quarter. And then last day in class, I should say. And then Wednesday, and review. Wednesday is your test. We'll do last minute review, and then you guys will take your tests after lunch. Alright, so looking on the first page, which of these do we want to see do go over, have questions about? 1. 3. 2. 5. And 8. Let's start with those. Alright, for number 1, you have to write an equation that is parallel to the given equation. So parallel means what about the slopes? They're the same. So I know it's going to be the same as this. So if you have to write an equation that has the same slope, it's going to start off the same. Y equals 1/3 x. Pick whatever y-intercept you want. This can't be the same. Someone give me a y-intercept. 4. That's it. That's all you have to do for that one. You're just writing an equation that is parallel to the one that is given. So they have to have the same slope but different y-intercepts. Questions on that one? Okay. Number 3, we are writing an equation that's perpendicular. So we have to remember the slope. I'm going to write toy box over here. This is an x equals, what is the slope of this line? Undefined. So I'm just going to write that as a side note. If it's perpendicular, it needs to be the opposite of that, which would be 0. So what equation is going to have a 0 slope? What type? X or Y? Y. So I'm going to write, for the perpendicular, we need a 0 slope, which would be a y equals. Since we're writing any equation that is perpendicular, it could be any y equals equation. So give me a number. 7. 4. These two equations would be perpendicular. It could be any number. Questions on that? So these are really your making up things. The slope has to be the same in 1 and 2. The slope has to be the negative reciprocal or opposite for 3 and 4. Right? This is where the work comes into play.
For number 3, would a fraction work as well?
Sure. Really, any number. You could put 6. This can be whatever number you want. For 4, the slope you would flip, make positive, and then the y-intercept could be the same, could be different, it doesn't matter. It could be a decimal, it doesn't matter. Alright, for these, we have to use our point slope. For reference, remember that this formula is somewhere over here in pink, point slope, and then it's over there somewhere else again, as well as over in the vocab words. So if this is parallel, we're writing an equation that's parallel to this one. The slope of our new line is going to be what? What do we know about parallel lines and their slopes? It has to be the same. So because we know it has to be the same, you could either write that m equals 6, you could circle that you're going to be using that 6 either or, something that tells you I need that 6. If it had some y-intercept, you would cross it out. You don't need that y-intercept. You now have your x1, y1, and your m to use in your equation. So y minus y1 equals m times x minus x1. So what's What's our first step? So we will distribute, but we need to do something else first. Yeah, make it a plus. So we do that on both sides. Y plus 3 equals 6 times x plus 1. Then distribute. Because if you distribute before you combine those, you might get the wrong answer depending on how you did it. Right, last step, how would we get y by itself? Subtract 3. I'm going to get a space here. Y equals 6x plus 3 would be an equation that is parallel to the original, has the same slope but a different y-intercept.
After you distributed it, did it just say 6?
So it would be 6x plus 6. Because it's really multiplying to the number in front. 6 times 1. Okay. Other questions on that one? Number 8. The number 5 was parallel. This one's perpendicular. So if it's perpendicular, we have to have a negative reciprocal slope. We have to take it, flip it, make it negative if it was positive, or vice versa. So what would the new slope be? Negative 7. You can put it over 1. You don't need it over 1, but just a negative 7 is necessary. We don't need this y-intercept crossed out. So now we have our x1, our y1, and our m. So y minus negative 5 equals negative 7 times x minus 1. Then we can distribute and make these into a plus at the same time. Get rid of the 5 by doing what? Subtracting. Y equals negative 7x plus 2. This is perpendicular to the original. It has a different negative reciprocal slope, different y-intercept. Are there questions on that one? Or other questions on this page before we move on? This one. Okay. So this one is similar to 1 through 4, but it's an added step. So 1, you have to find the equation of this line. So we know our slope, our y-intercept is negative 4. And it's going to be y equals something, something, negative 4. The slope of this line, if I were to count, there's a point here, here, there's a few points. So if I'm counting, I'm going up 2 to the right 1. So that would be a positive slope. So this would be the original. So we have to find the original. Then we have to find a parallel and perpendicular, or write a parallel and perpendicular equation. So if it's parallel, the slope is going to be the same. So it's going to start off the same. Y equals 2x. The y-intercept has to be different. Give me a different y-intercept. Sure. And that would be parallel to the first. Part B, we have to find something that's perpendicular. So what would the slope be? Not negative 2, we gotta take it, flip it, remember it's over 1. So negative 1/2. X, and then we can pick whatever y-intercept we want. It could be the same, it could be different. Someone give me a y-intercept. I heard the number, but not 2. 2, short. So find your original, figure out your y-intercept, count your slope, find your points. Find an equation that's parallel, has the same slope but different y-intercept, and perpendicular. Negative reciprocal slope, whatever your y-intercept you want. Go on to the next page. No, I'm actually going to say this front and back and the next front page, they're all linear regression or line adjusted. So we don't have time to do a bunch. But if there's like one from one page and one from one page, we could do a few. Are there any from this page we want to see you go over any questions about? Number 2. So, any questions like this? If it gives you a graph, this is one where you would graph these to see which one fits it best. Let's eliminate some. Is this in a positive or in a negative direction? Positive. So we can get rid of the negatives. Okay. Let's graph these two and see which one it fits best. Also be careful that this is counting by 2s. So we'd have a point at 2. And if it's 3/4, we would go up to the middle. 1, up 2, up to the middle is 3, and then over 4. These are by 1s though. It will look something like this. You're going up 2 and then up 1 more in the middle because of the graph. This would be the 3/4 one. It's kind of surrounding it. And then this would be the 4/3. So we'll start at 2, we'll go up 4, and over 3. So which one do the points surround more, the purple or the red? Or A or B? A. So with that one, you would just need to graph it to see which one fits it best. Try to eliminate if at all possible. Okay. Other questions on that page?
She did 3.
So this one, we want to find the line of best fit, but only using these 2 points. So in your calculator, you're going to reset it first. Second plus 712. And remember that you can use your notes. So the line of best fit notes, the one with all of the instructions, you will have that for this. If you don't write on the front, you will also have it for the test. We're going to go into Stat, Edit, so enter. And we need the 2 and the 12 in the L1. So 2 and then 12. And then 150 and 300 in L2. Once you have those numbers in, go back to Stat, scroll over to Calculate, number 4, linear regression, AX plus B, scroll down to Store Regression Equation, and hit Alpha Trace, and then enter 3 times. So this would be our equation, y equals 15x plus 120. Remember that if there are decimals, write at least 3 of them, rounding the last one. If there aren't decimals, don't put decimals. Part B, we want to use the equation we wrote to predict the height of a vertical drop after 20 years after 1988. So this is years after 1988. 20 years, we would just put in 20. So you could do one of 2 things, either put 20 in and then figure out what this is in the calculator, or store it as x, 20, STO, x, enter, and then alpha trace, enter twice. The work for this one, if you don't do this and figure it out, then the work you would say is you stored 20 for x in the calculator. Show that, write that as your work. You get 401 feet. Make sure you put your labels as the vertical drop in feet. And then I wrote in a part C. Is part B interpolation or extrapolation? Is 20 in part of the data or outside of the data? Outside. As a reminder, if you are given data points, so like this one, we were just given random data points, but like on the back, number 4, you're given years. Anytime you are given years, you have to change the first year to 0 and count how many years has it been since the original. So 99 to 2001 would be how many years? 2. 99 to 2003. So this would be 2, but 99 to 2003, what would that be? 4. 99 to 2005, and 99 to 2007. So always count from the original to the next one, not between the next 2. So always change those. Okay. Is there another line of best fit one you want to do? We'll do 5 and then we'll go on to word problems. So we're going to put this table, into our calculator first. In this case, would age depend on number of players, or would number of players depend on age? Opposite. Number of players would depend on the age. So this is going to be your y, and this is going to be your x. So we're going to go back to stat, go back into edit, go up to the top, hit clear, and scroll down. Do that for both. And then you can put in your data points. Once you get those data points in, go back into stat, scroll over to calculate, number 4, scroll down to store regression equation. Make sure you're doing this or later the rest of your problem won't work. Alpha trace, hit enter 3 times. This will be our answer for part A, write the equation of the line of best fit. Y equals negative 1.5x plus 34.1. We need the number, estimate the number of 12 girls that signed up to play lacrosse. So if we were to put 12 in for x, you can do that one of 2 ways. Either put 12 in here and put that into the calculator, or store 12 as x. So I'm going to do the second one, 12 STO x, hit enter, and then alpha trace and hit enter twice. So 16.1. 16.1 players. Make sure you're putting your labels on these. Okay. And then is 12 inside or outside of this data? Does 12 fall within these numbers? No, so would that be inside or outside? Outside.
Skip to the table.
You have to remember your different types. 3 of these are going to be set up as y equals mx plus b. I'm going to rephrase that. Where you'll be either given m and b and have to solve for y or x. 1 you may need to solve for b. 1 you may need to find the slope first and then solve for b. And then 1 you're comparing 2 different things. We may have time to do 1 of these before lunch. We could do possibly 1 when we get back. Are there any we want to see right now? This one? 15. Okay. So when Emma went bowling, it cost $4.95. I'm going to highlight out right. Per game plus a one-time fee to rent shoes. She played 5 games and paid $32. We have to write and solve a linear equation to find the cost to rent shoes. So, remember that's your M. The one-time fee would be our B, but we don't know what it is. So that means that's what we're going to end up solving for. That's going to be what we get at the end, the cost to rent shoes. So then 5 and 32, what variables would those be?
X and Y.
X and Y. Games would be X, 32 would be Y, the 32 would be like your Y1, or the 5 is your X1, and we're going to use our point slope. So if you have to solve for B, you're going to be using point slope. Y minus 32 equals 4.95 times X minus 5. Let's distribute. What is that multiplied by 5? Negative 5. 24.75. Right, and then if we add 32, what would that be? Okay. So for your equation, that would be your original setup, which you originally set up to solve. At the end, you should get a different equation. That's how it's put in here. Your solution, since we were looking for cost, would be B equals $7.25. Be thinking if you have questions on any other, and then we'll go over that when we come back from lunch, and then you guys will